Alrighty, so we're ready to get pretty heavy into our study of linear equations, and one of the most important concepts we have for that is rate of change and slope. And I know you've seen slope before. We're going to spend a couple days on it just to make sure you've got it, because you have to understand how the slope works, what the slope looks like, when you see a slope, what that means for the line. You have to understand those things in order to do what we're going to do this year. It's going to be a lot more intense than it was last year. First off, a definition. Slope is nothing more than the rate of change. And it says here, and I know it's a little tough to read for some odd reason, it blurred when it transferred over, change in the dependent variable over change in the independent variable. That means change in y over change in x, right? Because our y's are the dependent rather, and our x's are the independent, so those go on the bottom. For instance, again, nice simple example here, just a second. So for instance, if I have the following points 2, 3, and 7, 1, so the change in y's, that's 3 minus 1, that goes on the top. Change in x, 2 minus 7, that goes on the bottom. And I'm going to do some more examples of these, but just kind of get you warmed up to it. So what that really looks like is 2 over negative 5, or negative 2/5 is actually the slope. This is a line that would go down, moving from left to right. So to formalize that, again, slope is the vertical change over the horizontal change, or rise over run. The formula down here, m, that's what we call slope, y2 minus y1 over x2 minus x1. For 2 points, again, x1, y1, and x2, y2, the slope m can be found by this calculation. Note, the coordinate you first use in the denominator must belong to the same ordered pair as the coordinate you use in the first numerator. So we'll talk about that in the next slide. I'll do an example again for you. But again, slope, right? Rise over run, vertical change over horizontal change. So if I have the following 2 points, and again, 2 points what makes a line, right? 4, 2, and 10, 7. So I have to go through and identify some stuff. First off, we're going to say that this is x1, this is y1, this is x2, this is y2. Again, you could reverse the whole thing, but if you did that over here, this would have to be the 2's and this would have to be the 1's. Alrighty, so what that looks like then is the following. I'm going to, my formula, if you recall, m, right, equals y2 minus y1 over x2 minus x1. So, again, I always number them first above so I can, not forget what they are. So I'm going to have 2 minus, nope, see, I end up doing it backwards again. It doesn't really matter, does it? As long as you pick one or the other. So what that looks like then is 7 minus 2, right, over 10 minus 4. Pause here for just a second for you. So that gives you 7 minus 2, 10 over 10 minus 4. Gives you 5/6. And again, make sure you reduce the fraction. This one can't be reduced. So it's a positive slope, right? So rise over run. Let's give you another example. I know you learned last year how to count slope, right? So if I have the 2 points here, negative 3, 1, and 3, 4, I know you could count, right? You could go up 1, 2, 3, so 3 over, and then count over 1, 2, 3, 4, 5, 6, right? Which is 1/2. So let's see, does our slope m, does our formula work out the same way? So again, we have y2, so let's pick our 1's and our 2's. So we'll call this one y2, this one x2 rather, and call this one y1 and this one x1. So y2 is 1, y1 is 4, x2 is negative 3, and x1 is 3. Oops, 3, there we go. So if we do the work then, 1 minus 4 is negative 3, and negative 3 minus 3 is negative 6, which becomes a positive 1/2. So we get the exact same thing, whether we count the slope or if we go ahead and calculate the slope. So there you go, slope. And to review again this whole idea of slope, one more time with you. A positive slope goes up from left to right, so left to right going up. Notice going left to right, it goes up. A negative slope, when I go left to right, it goes down. A zero slope, perfectly horizontal, and a vertical slope, right, is undefined, right here. And we're going to have this also in your read and got it. So there you go.